Hello, this is Ian Kilborn, Energy Systems Engineering Technology at St. Lawrence College, Kingston, Ontario, Canada. This is an introductory video on how to model a building in RETScreen Expert. This is the home screen of RETScreen Expert. The version number is shown down here in the bottom left. Sometimes if you have a file that's created in a newer version and you try to open it in an older version, it won't work. Older versions seem to be compatible. Older files seem to be compatible with opening in the newer versions of the program, as they should be, but not necessarily the other way around. I have a separate video on how to do the location of your facility, so I'm going to skip over that. And we're going to go next to this tab here, which is the Facility tab. And here we choose what kind of a facility we want. Today we're doing a house, so I've chosen residential, and I've picked detached dwelling, single-family home. And these screens here are optional information. I can put titles, names, addresses, things like that in there. Down below here we have some benchmark information. So this is RETScreen's ideas about a typical fuel consumption would be for one of these buildings. And this is kilowatt hours per square meter. If you enter a number for square meters here, then it will give you some estimated overall energy consumption numbers down here. And this is probably electrical and heating combined. And over here we can see some targets or net zeros. That could be a topic of a completely different video. We're not going to enter anything in here right now. So I'm just going to move on here to the Energy tab, and this is where we're going to do most of our work. Once I've clicked on the Energy tab, I get a ribbon menu here with all kinds of useful things, and we can just start from the left and work to the right and fill in everything that's important for our building. I'm going to start with electricity and fuels here. When I click on this, I can see I've got some details in here, so I can come up here to electricity and fuels, and here's my electricity and fuels menu. Here's where I'll put the price of my natural gas. If it's not sold in cubic meters, you can change that here. So this is the price in dollars per cubic meter. Same thing for electricity. You can have your rate for electricity, and you can enter that right here. The next thing we need to look at here is the tab, or the section called Schedules. We can keep adding as many schedules we want by pushing the little plus symbol here. If you have different setbacks in terms of temperature set points for different parts of your building, or you have even just one occupied versus unoccupied, if you're going to have two different set points, then you need to create two different schedule screens. And you can then enter how many hours a day you're going to have it occupied and how many hours a day you're going to have it unoccupied. The very minimum you need to do is to put in a set point for heating, occupied heating set point. I'll put in 20 degrees there. If you don't put anything in there, as you get further in, you won't show any energy use. I'm going to put 16 degrees C as the heating and cooling changeover point. That is a default number that we tend to use all the time. It does affect the output a little bit. It comes from my experience with RETScreen 4, where that was the default. And I tend to leave that at 16, and I do not change it. The schedule here is the default schedule. And it's called 24/7. You can't change that. All the way down here it says 24 hours a day. So if we want to do a setback, we have to create a new schedule with the plus symbol here, and now it allows me to fill in both occupied and unoccupied set points, and the hours per day that it is occupied. So don't get that backwards. This is the occupied hours per day, not the unoccupied hours. I'm going to take that schedule away for now. You can navigate through here by coming across the top ribbon or coming down the tree here. I'm going to come across the top ribbon because it makes a little bit more sense to me. So step 1, fuels and schedules. Step 2, equipment. I'm not going to do cooling in this house. I'm going to do heating for sure. So I'm going to choose a heating system. Notice that your domestic water heater needs to be modeled here as well as your furnace. So I'm going to choose a furnace here. If I expand this tree here now, it's going to show heating furnace, which is what I'm starting to model. So I can put a note for myself. I can change the description. It's very good to have descriptions that are full and detailed, so you don't get confused later if you have more than one furnace or heating system, or perhaps in proposed case you're going to do something different. Again, have a pretty complete version of your information. So here it shows my furnace. When we begin to model a building, we always want to have base case and proposed case to be equal. Later on, we'll mess around with proposed case when we're looking at upgrades. So my fuel for my furnace is natural gas. It's sold in cubic meters. There's the price per cubic meter. I can't change that here because that was done up on electricity and fuels. My efficiency, I'll put over here. Notice that this is seasonal efficiency. It's not steady state efficiency. So this is equivalent to AFUE, annual fuel utilization efficiency. It is seasonal. So I'm going to move on now to end use. So end use means what is all this energy being used for? In our case, it's going to be used for mainly for heating and some for domestic hot water. So we'll click on this, and we have a whole variety of end uses that we can use this energy for. Down here is where we will do domestic hot water. Up here is building envelope. That's where most of our work is going to get done. So I've clicked on building envelope. Now in my tree view under end use, you can see that building envelope has opened up. Now here's where you have to do some strategic planning. You can create a number of different building envelope pieces. I'm going to call them zones, building zones. This is one right here. I can create more, and they will all consume fuel in different ways. When you're deciding how much of your building features and geometry to put onto one building envelope, there's a couple of things to think about. One is that you only get to have one heating system associated with each building envelope zone. So if I have more than one heating system, I need to create more than one building envelope zone, and so that I can associate different heating systems with them. One might be electric baseboards, for instance. Another one might be the furnace. So I would need to clump those together into different building envelope zones so that down here I could choose the appropriate heating system to go with that. Similarly, we only get to choose one schedule for this collection of building features, the building zone. And so if I have part of the building that runs on a different schedule than another part of the building, I want to make sure that I create those right here so that I can have zone 1 with a certain schedule and zone 2 with a different schedule. The third thing to think about when you're deciding about your building envelope zones are walls, windows, and doors. If I click on here, I get walls, but as you can see, there's only one section of walls available for this particular zone. So I may have in my building more than one type of above grade wall, for instance. These, by the way, are above grade walls. Below grade walls appear down here. So if I have more than one type of above grade wall, I'm going to need to put them on different building envelope zones because I've only got one R value here that I can associate with this wall type. If I've got wall types with different R values, I'm going to have to spread them around. That is if they're all above grade. If I've got below grade ones down here, that's fine. I can put them on the same zone as these ones. Notice how the windows and doors are between these two lines here. That means that whatever windows you model here will be cut out of the wall that you model up here. So you wouldn't want to model basement windows on the same zone as you modeled above grade walls, because the area of the above grade walls would get reduced by the windows that you put down here. Similarly, the doors that you put down here will get cut out of these walls. You don't have to reduce the area manually of these walls by the windows and the doors that are going to be in them. RETScreen does that in the background, but it takes these doors and these windows and it cuts them out of these walls. Similarly, we get to have one roof for this zone, one floor for this zone, and one wall below grade for this zone, and one version of air leakiness for this zone. So these things may all determine how you break your building up into zones. Some simple buildings you might be able to do as one zone. If you have only one kind of above grade walls, one kind of below grade walls, one kind of roof, and so on. There's a roof, and now this is very confusing where it says floor here. This is a cold floor, an above grade floor, a floor that is a thermal boundary that is not below grade. So for instance, if you had a crawl space underneath your floor that was not heated, this is where you would model that floor. If you had a garage below the floor that was not heated, this is where you would model that floor. If your house is a slab on grade or has a basement, this is not where you model the floor. You model the floor down here where it says below grade. Here the default comes up as on grade, even though it says below grade. So if we did a slab on grade, this is how we would do it. If we have a below grade floor, we just have a choice of whether it's insulated or uninsulated, and we move forwards like that. So say I wanted a uninsulated below grade floor, I would do that. I'm going to put my R values and my areas in these boxes here. Remember, the right-hand side all the way down is proposed case. For most of these building geometry features, you just click on this button here after you've done the base case, and it copies it all over to proposed. Windows does not always behave that way, but at the moment it is. This is where we are going to do our air infiltration. If you have a blower door test, your information is going to go here. Notice that the defaults for all of this stuff is leaky. That will throw your fuel consumption up into a very high level if you don't change it. I'll do a separate video on how to do natural air infiltration because it's a topic all of its own. So I've just entered some numbers in here for wall areas, and in this drop down here we've got a choice of 4 different sets of units for the thermal properties of those walls. This is metric, also known as RSI values. This is imperial R values. These are the common R values, like what you go and buy R12 insulation. That's the units for that. If you continue on down, instead of R values, you get U values. U is the reciprocal of R, so there's the metric and the imperial version of that. Be careful what you're doing. If you have the wrong units, everything goes crazy. The most common mistake that people make in modeling buildings in RETScreen is getting the units wrong anywhere. So I'm just going to copy my base over to my proposed here by clicking that button, and now it makes the base the same as the proposed. Up here I have the ability to indicate in degrees what direction my building faces. If I don't enter anything in here, it means that the north wall of the building, which is this wall here, faces exactly north. If I enter a number in here, I can rotate my building so that the wall that I'm calling north actually faces some number of degrees off of north. And you can go east or west of north depending on whether you make that positive or negative. So I've just entered our values in here arbitrarily. To do this properly, you probably want to actually model the walls by building them up layer by layer of the stuff that they're actually made of. You know, fiberglass, wood, studs, skin coefficients, all of that stuff. And to do that, you click on this little link here called Building Envelope Properties, and that will open up an appropriate worksheet that allows you to figure out what the R value should be. That will be the subject of a different video. So I've renamed my first piece here Zone 1 Building Envelope. If I wanted to add another zone, I can just come up here to Building Envelope. I can right click on it and I can say Add. I can also do it by going back up here to the Energy menu. If I click Add, it gives me another one here. And so I get a whole new set of windows, doors, walls, and floors that I can add on here. And I might call this Zone 2 Building Envelope to be nice and clear about that. So there I've got a Zone 1 and a Zone 2. As I start to build this stuff up, I can now come over and look at what's going on. So over here in Summary is where we can begin to see the results of our work. There's two screens available. This one called Include Measure gives us a summary zone by zone of our energy use and costs. The default screen that comes up here is quite confusing because it says energy saved. If you've modeled your stuff correctly, you should see zeros here because your base case and your proposed case should be the same. I generally like to look at either fuel consumption base case or energy base case as a time to see what's really going on. And these are energy units. You can't show cubic meters of gas here. You have to show energy units. It doesn't too much matter what you choose. If you choose the wrong one, the number might get very small and lose accuracy in its display, although the accuracy is still retained behind the scenes in the program. I'm now going to jump over to the comparison screen. This one is a little bit more useful, and it shows us now how much natural gas we have actually used in real units, and dollars. So we've used 6,000 cubic meters of natural gas. The price is 30 cents a cubic meter, and so the total cost is $1,800. Our proposed case, luckily, is exactly the same. That means we've modeled things correctly. We didn't forget to click one of those buttons that makes propose and base the same. Later on, we're going to look at reconciling with our utility bills. So if our utility bills said that in an average year we used 5,500 cubic meters of gas, I could enter that there. And this will show you then the variance. What is the difference between what you've modeled and what your utility bills are saying? If there's a big difference there, we've probably done something wrong with our model, and we're going to come back and we're going to work on that. If our base case and proposed case were different, we would show some overall dollars of savings up here. In this case, natural gas, because that's the only fuel that we've got. So here you're going to see savings sorted by different fuel types. Down here you see savings sorted by different end uses. So heating, cooling, electricity, and total. This will give you savings sorted that way. So you can see in one screen all the different savings that you've achieved by modeling an upgrade. We haven't modeled any upgrades yet because our proposed case is the same as our base case. So I'm going to conclude this video here and provide more videos with details of some of the things like how to model the R values. This is an overall picture and a first look at building energy modeling. As I said before, the most common mistakes that people make in RETScreen are to get the units wrong. So if you're getting very wild numbers that are not believable, go check your units.